Okay, so our topic today will be matrix operations. So operations on matrices, section 8.3, and our homework is 9 through 25 odd. All right, so we're going to start off with notation, the proper notation for a matrix. And what we do here is we use capital letters, mainly A, B, C, to denote a matrix. So any capital letters will do, but more than likely you're going to see A, B, and C. So matrix A, matrix B, matrix C with capital letters. Also, to denote like the specific elements in a matrix, so if we're talking about matrix A, we'll have in brackets lowercase a, and then we'll have I, J. Now, the I represents the but these are lowercase I and J. The I represents the row, and the J represents the column. So example, if we had A, 3, 2, what we are specifically looking for is in matrix A, which element occupies the third row and the second column. So in matrix A, we're looking for the element in the third row and second column. Okay. Now, the order of a matrix is the number of rows and columns that that matrix has. So that's how you determine the order. So a matrix has order and we say it's M by N. So we don't say times, but this little X there is by. So M by N. So an M by N matrix. And again, this matrix will have M number of rows and N number of columns. So that's an M by N matrix. If M is equal to N, then you get a square matrix. So let's say we have this example. Matrix A is equal to 3, 2, 0, negative 4, negative 5, and negative 1 over 5. So what's the order of this matrix? So the order would be, how many rows does this matrix have? 2. 2 rows. And how many columns? 3. So the order of matrix A is a 2 by 3 matrix. It has 2 rows and 3 columns. How would you describe A1, 2? Which element occupies that spot? So in matrix A, we're looking for the element in row 1 and column 2. So that would be 2. Here's row 1, here's column 2, so that element would be 2. How about A23? Which element is A23? Negative 1 over 5. So that's the element that's in the second row, and it's in the 1, 2, third column, so it would be negative 1 over 5. All right, so let's take a look now at the equality of matrices. Any questions so far? Already seems a little easier than the last couple of days. Yeah. All right, so equality. Two matrices, A and B, are equal if and only if they have the same order so that's the m by n, and every A sub ij is equal every B sub ij. So in other words, every element from matrix A from row 1, column 1 has to equal row 1, column 1 in matrix B. Row 2, column 2 in matrix A has to equal row 2, column 2 in matrix B. They all have to match up. That's the only way two matrices are equal, is if all of their elements are lined up. Now, we're not going to assess you by giving you a matrix where all of the items line up and say, well, are these two matrices, equal? More than likely, you'll get something like this. We'll let A equal B. So let matrix A equal matrix B. And we're going to say A is equal to X, Y plus 1, Z, and 6. And B is equal to 1, 5, 3, and 6. So if matrix A is equal to matrix B, then this allows us to go through and solve for our variables. So if these two matrices are equal, row 1, column 1 in matrix A has to equal row 1, column 1 in matrix B. So X equals 1. Row 1, column 2 in matrix A has to equal row 1, column 2 in matrix B. So Y plus 1 has to equal to 5. And now if we subtract 1 from both sides, we know that Y is 4. Row 2, column 1 in matrix A, which is Z, has to equal row 2, column 1 in matrix B, so Z is 3. And then, of course, 6 equals 6, the last one. So this allows us to solve for missing pieces of a matrix. Okay. Now we're going to move on to matrix addition and subtraction. Okay, if we have two matrices, A and B, then A plus B is equal to the element Aij plus Bij for every element in both matrices. you add the corresponding parts. So example, if matrix A is equal to 1, negative 2, 3, and 5, and matrix B is negative 1, 6, and then 0, 4, then what's A plus B? So our answer here would be, well, this is going to be 1 plus a negative 1. So row 1, column 1 plus row 1, column 1. Then we're going to have a negative 2 plus 6, 3 plus 0, and then 5 plus 4. So our final answer would be 0, 4, 3, and 9. So that's the mathematical operation of A plus B. Okay, so far? Now, using the same matrix A and B, how about A minus B? So A minus B would be every element in A minus the element in B that match up. So in this case, this would give us 1, negative 2, 3, 5, minus negative 1, 6, and 0, 4. So that would equal 1 minus a negative 1. And row 1, column 2, that would be negative 2 minus 6. Row 2, column 1, 3 minus 0. And then finally in row 2, column 2, 5 minus 4. So our final answer here would be 2, negative 8, 3, and 1. Now, what about B minus A? Is A minus B, are A minus B and B minus A the same? So think about it. 3 minus 2 is a positive 1. But 2 minus 3 is not positive 1, it's negative 1. So subtraction doesn't hold for real numbers, so do they hold for matrices? Well, let's try it. So using the same A and B that we used before, B minus A would be negative 1, 6, 0, 4, minus 1, negative 2, 3, 5. So that's going to give us negative 1 minus 1, 6 minus a negative 2, 0 minus 3, and then finally 4 minus 5. And our answer would be negative 2. Negative 1 minus 1 is negative 2. 6 minus a negative 2, positive 8. 0 minus 3, negative 3. And then 4 minus 5 is a negative 1. So we see that these two are not the same. In this particular example, it seems like each term is the opposite of it, of the term in the other set. So I wonder if we can draw any conclusion from that. Maybe, maybe not. We'll save that one for later. Okay, here is something that is key. The sum or difference. So that means adding or subtraction of two matrices with different orders is undefined. In other words, we can't do it. If you have two matrices and they have different orders, so what I mean is, let's say we have 1, 3, -4, and 2. Can we add that to 1, 4, 0, 6, 2, -3? We cannot add these two matrices because our first matrix is a 2 by 2. And our second matrix is a 2 by 3. The only time you can add and subtract matrices is if the orders are exactly the same. And in this case, we can. Now, when we get to multiplication tomorrow, that's a little different story. But as far as adding and subtracting, we can't do that. All right, questions? Okay. All right, let's go ahead and move on to the zero matrix. So our zero matrix, what that means is that all elements are 0. So a 2 by 2 zero matrix would be 0, 0, 0, 0. All of your elements are 0. If A is equal to 2, -1, and then 4, 5, then A plus the zero matrix would be 2, -1, 4, 5, plus 0, 0, 0, 0, which would be 2, -1, 4, and 5. So that's the additive identity. Just like with real numbers, if you add 0 to any real number, it doesn't change the value. That's the additive identity. So the zero matrix is the additive identity. Okay, what about the additive inverse? What's 3 plus a -3? 0. So -3 is the additive inverse of 3. And 3 is also the additive inverse of -3. So this works with matrices as well. So if we had A is equal to -1, 4, 5, then the additive inverse of A would be -A, and that would be -2, +1, -4, -5. If we add these two matrices together, we should get the zero matrix. So 2, -1, 4, and 5 plus -2, 1, -4, -5 does in fact give us the zero matrix. Now, this is important because we're going to use these properties later on in solving matrix problems. Almost done. A lot of information today, not so much tomorrow. One other thing I want to mention is two properties. So for matrices, A plus B is equal to B plus A. So matrix A plus matrix B is equal to matrix B plus matrix A. A minus B does not necessarily equal B minus A. It could under certain circumstances, but for the most part, that would be a no. A plus B plus C is equal to A plus B plus C. Do you guys remember the name for this property? Starts with an A. Our associative property. So if you're adding three matrices, it doesn't really matter the order. We can do A plus B first, get an answer, and then add that to C. Or we can do B plus C first, and then add A to that. So the associative property works with matrices. And now scalar multiplication. So what scalar multiplication says is if C is a scalar, then C times matrix A is really equal to C times each of the elements in matrix A. So you're just going to multiply every element by C. So example, let's say matrix B is equal to 2, negative 3, and 5, negative 6. Then 5 times B would be 5 times 2, 5 times negative 3, 5 times 5, and 5 times negative 6. Our answer would be 10, negative 15, 25, and negative 30. The scalar factor of 5 there. All right. All right, so our last part for today's notes is how are we going to use all of these properties of matrices to solve a matrix? And we'll just start right off with an example. 2 times matrix X plus matrix A is equal to matrix B. And we're going to define matrix A. It's 1, negative 5, 0, and 2. And matrix B, negative 6, 5, 9, and 1. Now, before we even start using our matrices, let's go ahead and isolate the X, because we're trying to determine what is matrix X. So 2 times some matrix plus matrix A will give us matrix B. So the first thing we're going to do is we're going to subtract the A, matrix A. So we get 2x is equal matrix B minus matrix A. Then we're going to divide by 2. But actually, I want to use language that we've been using with the matrices. So what's another way to say divide by 2? Multiply by 1/2. So if we multiply both sides by 1/2, we're going to get x is equal to 1/2 of matrix B minus matrix A. So matrix X would be 1/2 of matrix B minus matrix A. So now that's equal to 1/2 matrix B minus matrix A. So here's A and B. So that's going to be -6 minus 1. 5 minus a -5. 9 minus 0. And 1 minus 2. So those are the elements for matrix B minus matrix A. So that would be 1/2 of -6 minus 1 is a -7. 5 minus a -5 is +10. 9 minus 0 is 9. 1 minus 2 is -1. Now we can use our scalar multiplication. So 1/2 times this matrix would give us -7 over 2. 10 divided by 2, 1/2 of 10 is 5. 9 over 2. And then finally -1 over 2. So that would be our solution. So matrix X would end up being that. Now, let's double check that to make sure that this is truly the case. So we had 2 times matrix X plus matrix A is equal to B. So that would be 2 times -7 over 2, 5, 9 over 2, -1 over 2. Plus matrix A was 1, -5, 0, and 2. Well, multiplying each of these terms by 2, we're going to get 2 times -7 over 2 is -7. 2 times 5 is 10. 2 times 9 over 2 is 9. 2 times -1 over 2 is -1. Plus matrix A, 1, -5, 0, 2. -7 plus 1 is a +6. I'm sorry, -6. 10 plus a -5 is a +5. 9 plus 0 is 9. And -1 plus 2 is a +1. So, ladies and gentlemen, is that in fact matrix B? Yeah. So that is matrix B. All right, so that's it for today's lesson. So what do you think? Easier than